Dear students, welcome back. Let us take another tutorial example related to the discrete and Fourier series. So here we are taking x of n as, okay, let us see here. So the x of n is equal to 5 sine pi n pi by 2 plus cos n pi by 4. Okay, 5 plus sine n pi by 2 plus cos n pi by 4. Okay. So we have to find the discrete time Fourier series representation of the given signal. Now, first of all, let's find the time period of the given signal. So here we can see there are three terms in this x of n. The first one is 5, that is a DC component, which is frequency is equal to 0. The second one is in fact a sine component. The third one is a cos component. So the sine component is of the form sine omega n. Okay, sine omega n. So omega value is equal to pi by 2. Okay, here. So sine omega n. So that the omega is equal to pi by 2. So the time period n1 is equal to 2 pi by omega. 2 pi by omega. Basically time period 2 pi by discrete time period or 2 pi by omega. Okay. So 2 pi by 2. Okay. So the pi and pi get cancelled out. 2 goes to numerator. So 4 times m1. So 4 is an integer, so that we can take m is equal to 1. For integer ആണെങ്കിൽ നമുക്ക് m നെ 1 എന്ന് എടുത്താൽ മതി, so that n1 is obtained as 4. Now the time period of the second component, that is cos pi by 4 into n. So omega equal to pi by 4, 2 pi by omega, 2 pi by 4. So this pi and pi get cancelled. 4 goes to numerator. 4 times 2, 8 times m, which is equal to m8. So that is also taken. So first signal the time period is 4, second one the time period is 8. Okay, now let us find the overall time period of the signal. For that, let us consider n1 by n2, which is equal to 4 by 8, which is equal to 1 by 2, so that we can take cross multiply 2 times n1, which is equal to n2, 2 times n1, which is equal to n2. So n2 is equal to 8, and 2 times n1, 2 into 4, which is also equal to 8. So the overall time period of the signal is obtained as 8. Okay, so that is taken as 8. So n is obtained as 8. Here n is equal to 8. The time period of the signal is 8. Now, in order to find the discrete time Fourier series representation, we can expand the given signal. Okay, we can expand the given signal x of n. So we have taken x of n, 5 plus sine pi by 2 into n cos pi by 4 into n. Okay, so sine theta, what is sine theta? Euler's identity. Sine theta is e raised to j theta minus e raised to minus j theta divided by 2j. Okay, whereas cos theta is equal to e raised to j theta plus e raised to minus j theta divided by 2. Okay, so the sine theta is equal to pi by 2 times n, e raised to j pi by 2n minus e raised to minus j pi by 2n divided by 2j. Okay, whereas cos theta e raised to j theta plus e raised to j minus j theta divided by 2. Okay, divided by 2 only here. This is divided by 2j. Okay, so now we can expand it. Okay, we can now expand. The 5 is 5, then this term, so 1 by 2j is common. So 1 by 2j into e raised to j pi by pi n by 2 minus this minus sign is here, 1 by 2j into e raised to minus j pi n by 2. Now this term here, 1 by 2 into e raised to j pi by 4n plus 1 by 2 into e raised to minus j pi by 4n. Thus we are getting a total of 1, 2, 3, 4, 5 terms are here. Okay, now we can take the discrete time Fourier series equation x of n. X of n is equal to what? Summation k equal to minus 3 to, so k is equal to minus 3 to 4. Okay, so we have once again we have taken the period from -3 to 4. So since ck is periodic, so we can take any period. Okay, we can consider it from 0 to 7. We can take if n is equal to, since time period n is equal to 8 ആയതുകൊണ്ട് 0 മുതൽ 7 വരെ എടുക്കാം, അല്ലെങ്കിൽ 1 to 8 വരെ എടുക്കാം, -1 to say 6 വരെ എടുക്കാം, അങ്ങനെ ഏത് പീരീഡ് വേണമെങ്കിലും നിങ്ങൾക്ക് എടുക്കാം. So here we have taken k is -3 to 4 ആണ്. -3 to 4 once again we have taken ck e raised to j 2 pi nk by 8. So k യുടെ വാല്യൂസ് നമ്മൾ, so nk by 8 എന്ന ക്യാപിറ്റൽ N is equal to 8 ആണ്. So this cancel out ആയിട്ട് nk by 4, k nk by 4. So k ക്ക് നമ്മൾ ഡിഫറെന്റ് വാല്യൂസ് കൊടുക്കുന്നു. c -3 e raised to -j n k is equal to -3 by 8. So -3 യുടെ ആണ് ഈ മൈനസ് ഇവിടെ വന്നത്, ശ്രദ്ധിക്കുക. അടുത്ത c -2 j 2 pi n -2 by 8. In fact, നമ്മൾ ഇവിടെ നേരിട്ട് here we are coming directly from this equation. ഇത് നമ്മൾ യൂസ് ചെയ്തിട്ടില്ല. So again c -1 e raised to j 2 pi n k, that is -1 by 8. c0, c1, c2, c3, c4, k different values. K equal to 0, k equal to 1 കൊടുക്കുക, k equal to 2 കൊടുക്കുക, k equal to 3 കൊടുക്കുക, k equal to 4 കൊടുക്കുക. Okay, so equation അതിനനുസരിച്ച് modify ചെയ്യുക. So there is total of 8 coefficients are there. Okay, അല്ലെങ്കിൽ 8 terms ഉണ്ട് ഇവിടെ. അപ്പോൾ അതിനെ നമ്മൾ അടുത്ത സ്റ്റെപ്പിലേക്ക് ഒന്നുകൂടെ നമ്മൾ അതിനെ സിംപ്ലിഫൈ ചെയ്യുന്നു. ഫോർ എക്സാമ്പിൾ ഇവിടെ ഈ ഒരു 2 ഉണ്ട്, അതിനെ നമ്മൾ 8 കൂടെ ഡിവൈഡ് ചെയ്യുമ്പോഴത്തേക്കിനും ദിസ് -j pi n 3 by 4 എന്നായി. ഓക്കെ, ഇവിടെ ഒരു 2 ഉണ്ട്, ഈ 8 again -j pi n by 4 എന്നായി. ഇവിടെ സേ you can see 2 into 4, 8 ന്യൂമറേറ്ററിലുണ്ട്, ആ 8 8 ക്യാൻസൽ ഔട്ട് ആയി. സോ വാട്ട് റിമെയിൻസ് e raised to j pi n എന്നായി. അങ്ങനെ ഓരോ ടേമിനെ നമ്മൾ ഒന്നുകൂടെ സിംപ്ലിഫൈ ചെയ്യും. സോ c -3 into an exponential term, c -2 into an exponential term, c -1 into exponential term, like that. c4 വരെ നമുക്ക് 8 terms അവിടെ കിട്ടും. ഇതിനെ നമുക്ക് തന്നിരിക്കുന്ന given equation അല്ലെങ്കിൽ given signal, അതിനെ നമ്മൾ എക്സ്പാൻഡ് ചെയ്തു, അതുമായിട്ട് നമുക്ക് കിട്ടിയത് നമ്മൾ നേരത്തെ എക്സ്പാൻഡ് ചെയ്ത് വെച്ചിരിക്കുന്നത് അതുമായിട്ട് നമ്മൾ ഈ പെർട്ടിക്കുലർ ഇക്വേഷനെ അല്ലെങ്കിൽ ആ ഫോറിയർ സീരീസിന്റെ ജനറൽ ഇക്വേഷനെ നമ്മൾ കമ്പയർ ചെയ്യണം. ഓക്കെ, അപ്പോൾ ഇവിടെ 5 എന്ന് പറഞ്ഞൊരു ടേം ഉണ്ട്, നിങ്ങൾക്കറിയാം 5 ഈക്വലിന് ആയിട്ട് ഇവിടെ വരുന്നത് എന്താണ്, c0, ദാറ്റ് ഈസ് ദ DC കോമ്പോണന്റ് c0 ആണ്. സോ c0 ഈസ് പുട്ട് ആസ് 5. അടുത്തായിട്ട് എന്താണ് e raised to j pi n by 2 ആണ്. സോ വി ജസ്റ്റ് ലുക്ക് ഹിയർ ഇൻ എ ടേം, യു ക്യാൻ സീ ഹിയർ e raised to j pi n by 2 എന്ന് പറഞ്ഞൊരു ടേം ഉണ്ട് ഇവിടെ അല്ലേ. സോ you can see c2 is nothing but this one is equal to c2. So 1 by c2 is equal to 1 by 2j. Another e raised to j pi n by 2. So you can see here j pi n by 2. So this is c minus 2. Okay, so this one is equal to c minus 2. So c minus 2 is what? This one minus 1 by 2j. This is c minus 2 is minus 1 by 2j. So you can see another term here, j pi n by 4. Okay, j pi n by 4, j pi n by 4, that is c1. Okay, that exponent is multiplied with c1. So c1 is equal to what? Here c1, that is equal to 1 by 2. Okay, c1 becomes 1 by 2. Then this term that is related to here, this term c minus j. So we can say c minus 1 is equal to what? C minus 1 is equal to this 1 by 2. C minus 1 is equal to 1 by 2. So there are other terms here. C coefficient c minus 3 under, so that is not present in the given sequence. So we have to take c minus 3 as 0. C3 under, that is again taken as 0. C4 under, that is again taken as 0, because those terms are not present here in the x of n. X of n is 5 term that is representing C0, C2, C minus 2, C minus 1, C1. So what remains, the remaining coefficients is C minus 3, C3, C4, that is to be taken as 0. Okay, so in this way we are finding the Fourier coefficients. So this is how, so once we are getting the Fourier coefficients, that is the mark of, or that is how we are finding the Fourier discrete time Fourier series representation of the given signal. Okay. Okay. The coefficients are the unknowns which are in fact which we need to find in order to represent the signal by using the discrete time Fourier series representation.